So we are continuing with this example on censored reliability test, which is designed to stop as soon as a fixed number of samples fail. So here we have an example of a test starting with 9 samples and stopped as soon as 3 failures were recorded, and the time to failure for each of them was recorded, and we need to estimate the mean time to failure. What we have done already is we have derived the distribution for the time to the first failure, that is exponential with mean with parameter n lambda. We have found the distribution of delta t2, the time between the second and the first failure, that is also exponential with a parameter n minus 1 lambda. At this point, we want to ask the question, are delta t1 and delta t2 independent? It would be good to know because such information helps in the estimation process. So we start with the basics. We start with how we derived the CDF of delta t2. So now we are conditioning it on a fixed value of delta t1, and if we can show that that conditioning doesn't matter, the two events are independent, then we could conclude that the random variables are independent. So let's proceed step by step. We start with the definition of delta t2 in terms of all the individual x's, as we had done before. Remember that includes the time to the first failure, x subscript parenthesis 1, and in the conditioning event we now have delta t1 is equal to tau 1. So that is what we set in the previous line. Now we can proceed. Because delta t1 equals tau 1 essentially means that the time to the first failure is tau 1. So if we agree with that, then we can replace x subscript parenthesis 1, the time to the first failure, with the conditioning event that it is equal to tau 1. So our probability statement simplifies to the fact that all the x's are greater than tau 1 plus delta tau 2, except the one that failed already, given that all the others are greater than tau 1, except the one that has failed at tau 1. Now let's proceed with the algebra. We express that PA given B in terms of PAB over PB, because AB one already contains in the other. So the numerator is simpler. It begins to look familiar now, and if we just plug in the exponential nature of all the x's, we end up with two exponential functions, and when we subtract one exponent from the other, we are left with the conditional probability of delta t2 given delta t1 has a particular value. We get back the unconditional probability. So and this is, since this tau 1 was arbitrary, we can conclude that delta t1 and delta t2 are independent. So proceeding this way, we can show that the time between any two successive failures, delta tj, will be exponential with parameter n minus j plus 1 times lambda, and all the delta tj's are mutually independent. So we have come to a good point in this derivation, in solving this problem, is that the times between the successive failures, they are exponential, they are mutually independent, but they are not identically distributed. So that is one problem which still remains, because you see all the parameters, they are not the same. It starts with n lambda, then n minus 1 lambda, etc. So n minus j plus 1 lambda for the general case. So they are not identically distributed.